Okay, today we're going to take a look at some examples of composite and combinations. All right, so let's do this. Let's say we have three functions. So we have x squared. Let's do x squared, x plus 2, and then let's do square root of x minus 4. Okay, so here we have three functions, and we're going to be doing a whole bunch of stuff with those. Let me just make sure I don't want to put anything else here real quick. All right, so first, okay, so first let's take a look at a basic combination. Okay, so we're going to evaluate f plus g of -3. I'm going to give you guys 2 minutes to get started. All right, try to get it going, and then maybe not 2 minutes, maybe just a minute, and then we'll start going over it together. All right, so again, remember we're using the f function and the g function. There's two ways you can do this. All right, so I'll show you both in a minute. I'm going to go grab a water. I'll be right back. Okay. All right, so again, like I said, I'll show you both ways. So if you did one or the other, hopefully you see it show up. So the first thing you can do is you can combine the two, right? So you can find f of x plus g of x. In this case, there's no like terms. So you would just, you would just write it as a polynomial, right? So you have your x squared plus x plus 2, right? There's nothing fancy going on here, so you can drop the parentheses, x squared plus x plus 2. And then you can plug in -3. -3 squared plus -3 plus 2. Okay, just be careful. Remember, when you square a negative, it gets you positive. This, I'm just going to write, when we add a negative, that can change to minus. 9 minus 3 is 6, plus 2 is 8. Okay, so that was one way that you can do it. We're going to do it another way. Hopefully we end up with the 8. The other way you can do it is you can do them separately. Okay, you can find f of -3, right? That's just going to be -3 squared, which is 9. I could find g of -3, which would be -3 plus 2, which would be -1. Then I could do f of -3, plus g of -3, which would be 9 plus -1, which does in fact get me 8. Okay, so if you're doing, this could be minus, multiplication, division. Any of those would work for that. Any questions for this first one? Okay. We got room down here. All right, so they may also ask you to find the domain, like we talked about last week and the week before, of a combination or composite functions. Okay, so remember, anytime we have normal polynomials, our domain is all real numbers. Okay, so if you'd like to, do each one separately before we begin, right? Domain all real numbers. The domain here is all real numbers. Here, I need x to be greater than or equal to 4, right? That's our rule for square roots. It has to be greater than or equal to 0. Okay, so if you have all these labeled before, right, it might help you out later on when they ask you for the domain. All right, let me see. We're going to do 2 here. I'm going to do okay, we're going to take a look at h over g and then g over h, and we're going to compare the domains. Okay, so when I have h over g, well, we're just going to put them in a fraction form, right? So h goes on top. H is the square root of x minus 4. G is x plus 2. All right, so we have 2 things going on here, okay? For my domain, for my numerator, okay, like before, I'm going to show you how I got this x is greater than 4. Again, you take what's inside the square root, and that you set greater than or equal to 0. Okay, I believe we went over that, if not last week, 2 weeks ago, right? We solve and we say x is greater than or equal to 4. Okay, so that's for the numerator. For our denominator, we have a special rule. Nope, that's not how you spell denominator. Our rule is we can't have 0 in the denominator. So I have x plus 2 can't equal 0. So x can't equal negative 2. Now let's think about both of these, because sometimes one kind of negates the other, right? One of them might be not necessary. So for the numerator, x has to be greater than or equal to 4. And again, for the denominator, x can't equal negative 2. Well, negative 2 is less than or equal to 4. I need x to be greater than 4, right? So this is already, this condition is already met in my numerator. So we would say the domain is, we just have to worry about x is greater than or equal to 4. Okay? If I had this switched and this was negative 4, well, then this would come into play because that would fall in here. Okay, again, let me show you on a number line. That's a ugly line. All right, so we got, I'll put 0, 4, negative 2. Okay, so when x is greater than or equal to 4, this is my domain up here. I would put an open circle here to show it's not equal to 2, but I can't be down here anyway, right? This is my domain up here. So this doesn't take into consideration, okay? If this was switched, if x was less than or equal to 4, okay, then I'd have to state that it can't be -2 as well. All right. We can also show this in our interval notation, right? I can say from 4 to positive infinity. All right, so that's the first example there. Now let's flip it. Let's do g over h of x. Well, g was x plus 2, and my h was the square root of x minus 4. Again, let's take a look at them separately. So first we have the numerator. Well, in the numerator, this is the normal polynomial. So my domain is all real numbers for the numerator, okay? I no longer have any restrictions here. All right, not like this because I had a square root. For the denominator, I can't just say what I did over here because I can't have 0. So this changes now because this is in the denominator. So instead of writing x minus 4 is greater than or equal to 0, I'm just going to put greater than, all right? Because we can't equal 0 because it's in the denominator. So I would solve for this one. I would say x is greater than 4. Again, no equal to, right? So that changes our domain. Now I have an open parentheses from 4 to infinity. Okay. All right. So depending on the order, it may change the domain. Now, luckily, if we're subtracting or adding, okay, that's not really going to do anything. We can deal with this, right? For both of these, right, the domain is all real numbers. Okay. If I included h of x, if I added or subtracted, right, I would still only worry about the restrictions on this. X is greater than or equal to 4, right? If I added one of these two, or if I subtracted one of these two, that wouldn't change what happens here. All right. Now, I'm going to show you one more example, okay, with composite. All right, so I'm going to use f of x and h of x. I'm going to flip over here. I ran out of room. Okay, so we're going to find the domain of a composite function. Oops. H of f of h of x. All right, so let's do this like we did last time. So I'm just going to write up here, f of x was x squared. H of x was the square root of x minus 4. Okay, so again here, my domain was all real numbers. Here my domain was x has to be greater than or equal to 4. So I am going to, the first thing when we do composite, I'm going to substitute in what is this inside function. So I'm going to have f of the square root of x minus 4. Okay, again, all I did was substitute in what h of x was. Now what this tells me is in my f of x function, I'm going to replace x with this phrase. So I'm going to have the square root of x minus 4 squared. When we simplify this, okay, they eliminate each other, right? The squared and the square root are inverse operations, and all I'm left with is x minus 4. Now, looking at this, my domain changes from x is greater than or equal to 4 to all real numbers. Okay, so we have that we have to look out for. All right. Oh, I lost you guys. Okay, we're back. All right, so that would be with the composite. Now let's do, yeah, we got 5 minutes. Let's do some evaluation. do g of h of 8. Let me rewrite g up here. G of x was x plus 2. Okay. So again, I'm going to do this both ways to show you. Actually, no, there's only one way to do this, essentially. All right. So first, we're going to take, right, we work inside our parentheses. So first, I'm going to do h of 8. So we calculate h of 8. Right, I'm plugging in 8 in here. This fortunately works out, right? 8 minus 4 gives me 4. The square root of 4 is 2. Okay, so again, I have h of 8 equals 2. This is what I'm going to substitute in for h of 8 now. So I'm going to rewrite my function notation as g of 2. Okay, go up to g. G of x is x plus 2. So that's going to be 2 plus 2, which gets us 4. Okay, yeah, I don't think there's really another way you can go about this. I mean, you can plug this in. Okay, so another way I guess you could do it is you could calculate, or you can simplify g of h of x. So that would be g of x minus 4, the square root. So you would just be plugging in the square root of x minus 4 into g. So that would get you the square root of x minus 4 plus 2. And then we can plug in our 8. All right, that would go in there. And essentially, we're just doing the same thing. It's just written all out at once. Okay, I think this way is a little longer because you actually have to come up with your, composite function. Here, you're just doing kind of, like I said, it's kind of like a chain reaction, right? You plug this in, you get an answer. That answer, you plug that in. Okay, you may have to do this another time. There may be, an F outside of this, or another G or an H. All right, it's the same process. You just work from the inside. You calculate the inside, that goes to the outside. If there's something else in there, that would go to the next one. Okay, I'm going to end the lesson here, but please hang on.